Welcome to a new video series on the Nim programming language, Metaprogramming in Nim. Introduction. Metaprogramming is Nim's most advanced and most powerful feature, and it consists of the following components: constructs, generics, templates, and macros. Metaprogramming is a feature of Nim that gives you the ability to treat your program source code as data, just like how we used and manipulated the data inside variables in the Nim for Beginners series. With that said, metaprogramming allows you to write code that reads, generates, analyzes, and modifies other code. Generics. Generics are a feature that allows writing code without knowing the type beforehand. For example, when we overloaded procedures in a previous Nim for Beginners video. Generics will generate code based on the type used or explicitly specified for the generic procedures that will use them. For example, if we wanted to have a procedure to work for both integers and floats, we could either overload the same procedure with a different type or use a generic. Let's demonstrate this. So here we have a procedure that takes an integer type and returns the sum of integers, and then this same procedure, sum, is overloaded for float. And here is the generic version for the same effect. To make a generic procedure, first, before the arguments in parentheses, you have to specify the type. So in square brackets, t, and then you assign the data type of this t to the variables you want. So t, and then return type of t. Now let's echo the first normal procedure and its overload, and then the generic. So simple echo, first for whole numbers 1 and 2, and then for decimals, floats. Let's first run it, and then for generics. Here we go, 1 and 2, 3, and 2.0 for 0.5 and 1.5. And now for generic, let's copy this generic version and rename it to generic and generic, and let's echo this. Here we go, exactly the same result. Multiple generic types. Note that you cannot mix different data types of the same generic type. If you make a generic procedure with a single generic type, say t in our case, and if you give that type to both arguments of a and b, then both of them will have to use the same data type. The following code will error. This errors because the compiler doesn't know how to infer the data type here. Did you mean integer float or float float? Both must be of the same type, so we must explicitly tell the compiler that the first argument of 1 with no decimals is also a float, by telling it to use the float data type for this generic procedure like this: square brackets and then float. What if we wanted to have in our generic procedure, along the two generic types, so a and b as type t, a third argument that would have a different generic type? So these problems down here wouldn't happen. We could do this like this. Let's first copy the procedure down here and 2. Now to make another generic type, all we have to do is in the square brackets add a comma and pick a variable name for this generic type. So u, and then let's make a third variable. Let's call it c, and then as u. Now, in order to demonstrate this properly, we're not gonna call this sumGeneric2 with an echo sumGeneric, but we're gonna put the echo right in here. Also, we're gonna get rid of the return type, and now echo a plus b, which will display the sum of these, and then let's separate, and then c for its value, and then c, and now let's call it. So sumGeneric, let's give it 1 and 4 for the integers, and then some string of hello world for the c argument. And now let's run this. Here we go, 5, and then c is hello world. Constraining generics. If we wanted a generic procedure to use only certain types, we can easily do this like this. Proc our constrained generics, so some generic constraint, and then for its generic type t, we give it a colon, and then the data types we want it to be constrained to. So let's say integer, and then we use this symbol for or float, so it will be constrained to integer or float. And then of course arguments a, b, type t, and then return type of t, and then sum a plus b. This will exclude every other data type from being valid. For example, if we wanted to use our sumGeneric procedure with strings, it would error because we were trying to use the plus operator for arithmetic operations on a string. That will not work, obviously, as we need to concate it with the AND operator. So by excluding the string data type among others, it cannot cause an issue. Templates. Templates are Nim's second metaprogramming feature, and by being second most powerful and complex. Templates like generics are a way of reducing code size and make your code more readable and of course speed up development time. Templates internally take the code you give them and insert it at the called location. So you could use a template to, for example, clean up your game's main logic to make it easier to navigate and read. Then use your code editor of choice, go to definition functionality to jump where the code is. This works with procedures, etc. So here is an example from my Nim SDL2 Game Development for Beginners video series. We could make this code much simpler to use and read by using a template. We're going to get rid of all these if statements and strip it down to just arguments. First, let's comment out the player's movement code. And now let's make our template. First, we write the template keyword, followed by the name, just like with procs. Then for its arguments, we will give it scan code, coord, dir with no type, like this. Movement with collision, and then scan code, coord for our coordinates, and dir for the direction, and then no return value. Next, we need to check if a button is being pressed, just like the code we are stripping down. So if scan code is larger than 0, meaning our buttons are pressed. If scan code larger than 0, then we check for collision identically as before. We can copy this, followed by the same code for changing the coordinates of our player, but with times dir at the end. So let's copy this and change the x to coord and then times dir at the end. This is our template finished. So here with .coord, we change from x or y to coord. Template will simply take the coord, meaning whatever argument we give it, and we will give argument of x or y. This template will simply insert that x and y here, and then it will execute like a player.x or player.y. Then instead of using plus equals or minus equals, we are going to be using only plus equals because we don't need to subtract or add because we're always going to be adding a value. So if we give it a minus 1.0, that will subtract, and giving it a positive 1.0, that will add. So the negative one is completely unnecessary. And then finally, we're going to call it 4 times for the 4 buttons we're pressing to move. So movement with collision, and then for the first argument of scan code, we still have to use KBD and square brackets for the scan code to work. Now the first scan code up, and then the coordinates we're going to be changing, so y, and then -1 because the top is up here in reverse to the normal coordinates. Now let's copy this, and again, now let's change scan codes to proper values. Scan code left and scan code right, and now we make this one positive to go down, keep this one at negative to go left, and this one positive to go right, and also don't forget the set it to the x coordinate, of course. Now, to properly test this, we're going to be using the third SDL videos project to test this out. So let's copy this. Here I have the copy already set up. So by the way, the naming of the SDL2 Nim module has changed. So SDL2 has changed to SDL2 Nim. So let's replace this to SDL2 Nim. And for the second occurrence, now let's find a proper location to put our template at. Over here about the main program. Here we go. Now let's copy the calls and insert it at the location. Let's comment this old code out and put the calls here. Indent it. Now let's run this. It doesn't work because we have this file open as a file and not as a folder, so it doesn't know from where to look for the images that we are using in this project. So we're going to fix this. First, we need to import OS, from which we're going to be using the proc to get the application directory. Here we load our images. So get app directory. Don't forget parentheses, and then the and symbol to concatenate, and then also a slash, otherwise it will not work. Now the same for the wall image, and slash. Now let's run this. Here we go. It works. Different meaning of the return keyword in template. Templates share some similarities with procedures. They take arguments of types like procedures and can return values of some data type. But the return keyword, instead of returning the value like a procedure would, it will instead exit the template, return from the caller. So the following code will not work. Now this code will work. Let's copy this and give it 2 and comment the previous one out so it doesn't give us an error. And now remove the return keywords. Now this will work. So let's run it with echo sum template 2 and give it 1, 4 for integers, and now for float 0.5 and 1.5, and run this. Here we go. 5 and 2.0. It works. The reason for this is that a template call produces a direct template expansion. So the return version is turned into echo return 1 plus 4, which is not valid Nim code. The return keyword produces a return inside the calling context. This can be useful sometimes. Typed versus untyped. In this template, we have also not used any of the known data types, but instead we used untyped for the data type of the two a and b variables, as well as the return values data type. Untyped means that the data type of the arguments given to the template is not checked for symbol lookup and type resolution, which is necessary for passing undeclared identifiers, meaning you can pass not yet existing data types, etc. This is necessary for code manipulation. Templates using untyped for all of their arguments are also called immediate templates. Templates can also use the typed data type for their arguments and return values data type. Typed obviously means the opposite of untyped. Here is an example of declaring a variable with a template, untyped versus typed. Here's the untyped version. Template keywords, the name of the template, x is untyped, and then the body, var x is integer, the declaration, and then calling this template, x, and then x is free. Now this works. And now for the type version, it's exactly the same, except instead of untyped, it's typed, but now this doesn't compile. Some more facts on templates. Templates do not open up a new scope, but local variables inside the template are hidden from the callers. This is exactly what you need most of the time, but a variable can be annotated with the inject pragma. Pragmas are Nim's way of giving the compiler additional information commands. And then with the inject pragma, the local variable is visible in the template expansion context. Macros. Macros are Nim's most powerful and complex metaprogramming feature. They are the most difficult feature of Nim to learn, but once you do, your imagination is the limit. In programming languages without metaprogramming features, one manipulates and works with data, but in languages with powerful metaprogramming features, Nim obviously, you can also manipulate and work with code itself, form it into whatever you want. With macros, you do not work on the code like we do with its textual representation. The way macros manipulate with code is with an abstract syntax tree, AST in short. Macros allow you to easily write DSLs, domain-specific languages, much easier than in other programming languages. Domain-specific languages, DSLs, being for example JSON or XML, or transferring data over the internet. Macros allow you to write syntactic sugar, helper macros to make writing of code easier or to your liking. Macros allow you to write not just DSLs, domain-specific languages, but also entire languages if you so desire. These are just some of the examples of what macros can do. There are some limitations for macros though, mainly no FFI, foreign function interface, which is used to access shared libraries from other programming languages, for example using SDL. dumpTree macro. Now, the very first example of a macro I will show you will be a macro that does the exact same thing as our sumGeneric and sumTemplate examples did. Take two arguments of A and B and return the sum of them. But before we do that, I will show you how to get the AST from any code. To do this, simply type dumpTree followed by the code you want to get the AST from, like this. dumpTree A plus B. Also, don't forget import macros. Now let's run this, F6. Now, in order to be able to see the AST, we will have to switch to the Output tab from the Terminal 1 and select Nim. This is what we get. This is how Nim's AST looks like for our A plus B operation. The first line, SMT list, is the list containing the AST of A plus B. The second indented line, infix, means that there is an operator, plus sign in our case with two arguments. The third line, indented a second time under infix, is infix's body. It starts with the ident, short for identifier, plus sign, telling us that there will be addition, followed by our two variables that will be used for the addition. This is how Nim sees the code we give it and then processes it. Now, we can write this A plus B AST with a static statement used for compile time execution, though this would just display the AST in the output window. In order to actually execute AST code that we would write, we would have to use a macro. Quote do tool. There is also a very nice tool, quote do, that lets you write code and then it will generate the AST for you. This allows us to write a macro that does A plus B very easily. Let's demonstrate. Write the macro like you would a template and then init quote do, followed by A plus B with AB variables in backticks. So macro, sum macro, and then AB as untyped, then return value of untyped, and then quote do tool, and then in backticks A plus B. Now let's echo this with the exact same values as before. So some macro 1, 4, and copy this line or floats 0.5 and 1.5, and now let's run this. Here we go, 5 and 2. Constructing a macro version of our sumGeneric procedure or template. Now I will show you how to write a macro to do A plus B operation manually. This process is quite a bit more complicated. First things to note is that all arguments passed to macros become Nim nodes. Therefore, whatever value we pass it, we will have to determine its data type ourselves using getTypeInst, short for instance on our variables. Turn them into string and then compare its string, which we can output to see what it will be, to the string representation of a data type, integer and float in our case. Let's copy the body of this macro up here and then comment it out so it won't interfere. Now we have to change the untyped to typed. Now to repeat, all past arguments become nim nodes. Now we will use this getTypeInst to get the string representation of the type inside the nim node and then compare it to string of integer to be able to convert it. So if $a to convert it to string followed by getTypeInst is equal to integer, and then for b, so $b dot getTypeInst is equal to integer, and then for its body converting from nim nodes to integer value. So we need a new variable, so var x, different name, is a dot integer val, and then var y is b dot integer val. This will convert it from nim node to integer. Now let's also echo to see the result. So $a get type inst, and let's copy this line for b. Now let's call some macro, value 1 and 4, same as previous examples for integer. Now here don't use echo or discard on the macro because it will error, because the macro isn't finished yet. Nothing has been added to the implicitly returned result variable yet. Here our two past arguments are of type integer, while the converted two are of type biggest integer when displaying the type inside of a macro. It will display its macro representation. So if we display the type of the return value from our sumMacro, it will display it in the usual way of integer instead of biggest integer. Now let's run this, F6. Here we go, integer, integer. Now that we have our two past arguments of a and b converted from nim node to integers, we can now construct the AST for the a plus b operation by using the AST gained for the dumpTree macro used on the a plus b operation. So let's add to our if statement at the bottom, result is, copy paste the dumpTree AST. Firstly, remove these echoes so they don't interfere with the outputs, and uncomment the dumpTree and run it again. Now let's copy this, and result is, and ident this. Now we have to modify this AST into the corresponding procs that will add the corresponding AST to our result variable. SMT list will become new SMT list, and we put the last parentheses at the end so that this is in it. Now for infix, we simply lowercase it and give it parentheses because these identifiers are in it. Now here we will have to change the ordering a bit. This plus will go in the middle. But firstly, let's change the a, which will now become new integer literal node, and then in parentheses the value we're going to give it, so x, the converted value, and now the same for the second one of b, also a comma, and then y, and now we remove the identifier plus because it's going in the middle, like so, and we give it into string. Also, we got an extra parenthesis here, and stmt is the name. Now to display this using echo, add echo and run this, F6. Here we go, 5. We have successfully recreated a plus b operation using a macro. Now let's do the same for floats. So we're going to copy this, put it here, and make it an elif, and this remains the same. This becomes float, but not float, but float 64. Very important, it will not work otherwise. Here in the convert, we give it float, and the same for the second variable, and then again for the new node of float, but with an uppercase, and the same for the second one. And now let's echo a float version, 0.5 and 1.5. And now let's run this. Here we go. It now also works for float. Things you must remember about macros. All arguments passed to macros gets turned into nim nodes, data type, nim's AST nodes, except for special parameters such as static t and type dct. A macro must also always have a return type, and it must always return a valid AST, even if that AST is essentially empty. Style note. For code readability, for when you revisit your own projects or share them with others, it is a good idea to use the least powerful programming construct that still does the job. Don't use a macro when a template can do the job, etc. Here is a good list to follow. Ordinary proc iterator, generic proc iterator, followed by template and macro as the most powerful, least to be used. Okay, that's it for this video. Thanks for watching. Like, share, and subscribe, as well as click the bell icon if you liked it. You can also follow me on Twitter of the same name and support me on Patreon. If you had any problems with any part of the video, let me know in the comment section. The code for this video is in the link in the description, as well as the link to this video's documentation script. It is a form of offline tutorial. Have fun!